Welcome everyone. My name is Steve Myers, and this is an introduction to how an economist might do exploratory data analysis. Now, this may be a little bit different than what one would find in a standard text on exploratory data analysis, and you'll see why as we go through that there's kind of a holistic approach here leading to the ultimate analysis. So this is part one of a presentation based upon a paper that you can get at my GitHub that I gave at the Midwest SaaS Users Group meeting in Chicago in 2019. So this is part one, preparation for analysis. Now, as we begin to prepare for analysis, one of the things that we realize is that data is very time intensive. It takes time to do the kind of work that we want to do. Hasty data work is my phrase for not really spending the amount of time that one ought to spend in order to do quality analytics. So how do we get to quality analytics? And I think the first thing is we try to understand what hasty data work is. If you do not consider the problem and well articulate it, you're likely to be heading into your data looking for something about something, but you're not really understanding what is the best way to articulate the problem for testing, for questioning. In fact, this is a very long process sometimes to actually say, how do we answer this question? What are the ramifications? What are the differences? In fact, we're kind of laying out a whole process of analysis here as we articulate the problem. And we do so sometimes both in a theoretical context of, what if and what are the most important variables, as well as the practical context of what if we can measure these variables, how well is that measurement, and so forth. And this is where it starts, having good problem articulation, followed by, again, hasty work would be insufficient cleaning of your data, not spending enough time understanding what is in your data. Popular textbook that I just was using had an example of a regression, and the data was there, and I ran the process, and what do I find? I find that the data is full of what looks to be anomalies. So the regression coefficients that are properly shown in the econometrics text really can't be trusted, not without understanding whether or not the data was cleaned properly. The other part of it is, here's the regression and it's got certain variables in it, but do we consider what the proper data transformations were in order to really address the articulated problem? Probably not. What if we then use poorly developed and naive modeling? So we might say, hey, I want to know whether or not this thing, which we're measuring as a dummy variable, has an impact on something else, our output. And maybe this is our whole problem. Does this dummy variable affect everything? And what we might do is just run what I consider a hasty regression, run a regression model, put a few variables in there, put in the dummy variable, and whatever that dummy variable tells you, you just stop at that point and say, I'm done. Well, that's extremely poorly developed modeling structure, and not only is it naive, it's going to lead you to some very bad conclusions. And I have an example in future parts of this video on exactly that. If we really want to test, for instance, if we want to not only test our coefficients, but to establish causality, we have a lot of groundwork to do in order to get there. And if we don't do this groundwork before we run the model, we certainly can't expect the model that we run, which doesn't pay any attention to this, to give us the proper conclusions, and we end up having unreliable conclusions. Biggest reason for hasty data work probably is pressure, time pressure. If you have a boss who is saying, I need this and I need it by the end of the day or by tomorrow or the weekend, no later, you're going to be pressed into getting the work done. And many people talk about the fact that data cleaning itself can be 80% of the whole problem. So you have to get this done by today, by tomorrow. Maybe you focus on data cleaning. Maybe you don't have enough time to do that, and you certainly don't think of everything else, and you end up doing what I consider hasty work, and you get all the problems that come with that. The other is just our own temptation. We have data and we want to get results. We trust the data a little bit too much. And we want to go into the data and get our answers very quickly because we're busy. We want to go on. We want to do other things. We don't want to spend all our time on this problem. And we end up coming to a solution that turns out is very costly. Hasty work is costly work. But the problem is we can't get around this. Data takes time, and there's really no substitute for doing good work. Peter Kennedy writes in his Guide to Econometrics, a very good textbook. And if you don't have a copy of this book, Peter is now passed. The latest edition, I think, is 2008. I would grab this and I would put it on your shelf and treasure it. It is one of the best books written about applied econometrics, bar none. And most of it comes out of his chapter 22, which is on applied econometrics. I've written about this, as you see the link in there, because I think what Kennedy laid down was he laid down rules for ethical work with data. And if you're going to work with data, you need to do so in a way that doesn't compromise what it is that you're coming up with. So back in 2002, Sending in the Basement comes out. It's published by Peter Kennedy. He is a research editor at a major journal, and he sees a lot of work coming across his desk that, as he described, was just dumb. They didn't do things that were very obvious. They left out things, they assumed things, and they hid things from the editor, hoping it wouldn't be caught. Well, rule number one that Kennedy talks about goes to this problem articulation. Use common sense and economic reasoning. Now, I think these rules are pretty universal for any kind of analytics. So if you're a business analyst, use common sense and business reasoning. Try to figure out what is it about the problem that makes sense, indeed common sense. My major professor at Ohio State used to tell me that if the economic results didn't make common sense, it was probably wrong. Certainly there's research from time to time that reveals things that aren't commonsensical, but my goodness, that happens very rarely. It's the failure to put the thought in ahead of time that often leads to results that are just unbelievable. We all know, if we've had any statistics at all, what a type 1 and a type 2 error is. That happens to be making a wrong decision. What's the probability of, in the case of a test that might be, well, a courtroom, what is the probability of convicting the innocent or letting the guilty go free? Those are real errors made in a real test example called a courtroom, and those are type 1 and type 2 errors. Everybody understands these pretty much. What we don't understand is what Kennedy talks about as type 3 error. And a type 3 error is getting the right answer to the wrong question. So if we don't really think ahead of time and try to set this problem up to solve the problem, we may end up just say, run a regression and take a look, and here's a t-test and it's significant, and we realize that's not the right test. But interpreting that t-test could be done well, and you get the right answer, but it's not the question that you're seeking because you haven't done the work to get to that point. Rules 3 and 4 is really exploratory data analysis. Know the context of the data. Know the data generating process. I like to say that economists are obsessed with the data generating process because that's how we do our work. That's how we try to figure out whether or not things make sense. And of course, inspecting the data, just doing the exploratory data analysis. And the rest of these are all very important. I'm not going to talk about all of them. I really do refer you to the paper, which you can find Google Scholar, or you can get a copy of his great book and read this chapter on your own. I do want to comment on rule number 7, though. Economists are not fond of data mining. In fact, for much of our upbringing in the last few decades, uh, data mining would be anathema to the type of analysis that an economist would do. However, lately, economists are being hired by companies like Amazon in hundreds of people being hired. One article talked about 130 being PhD economists being hired to work in their area because they bring something that typical machine learning doesn't bring. They bring what? They bring causality. They bring the ability to think and to put together common sense economic reasons, articulate problems, and so forth. Economists are uniquely trained for this. I like to say that economists put the science in data science. And the example that I hold up is look at Amazon, Google, and so forth, and the tremendous demand for econometricians. So why didn't we like data mining? Because it starts with the data. And economists do not start with the data. At least we try not to. Now, one of our problems in economics is we're not a laboratory science. We can't go back and create data. Yesterday, which is captured in data, yesterday happened once. We can't go back and redo yesterday. We have to work with the data we have. And that actually creates monumental econometric problems, of which some folks, like Jim Heckman on the selectivity problem, have won Nobel Prizes for solving these complicated mathematical issues. But what does data mining often do? And maybe I'm painting with too wide of a brush, and perhaps I'm pushing the extremes here, but I want to make a point. And that is that when we fail to articulate the problem first, we end up looking at data as we see here. Data is first and leads to questions or answers, and questions lead to answers, answers lead to questions. What do we mean by this? Well, Ronald Coase, a Nobel Prize winning economist, said if you torture the data long enough, it'll confess. So we just apply technique after technique after technique, and we look for correlations, and we look for minimizing mean square errors or absolute deviations or whatever it might be, and we're coming up with then a model that comes from data alone. We're pattern seeking. If we're pattern seeking, we're not thinking. We're not thinking about the problem. We're not articulating the problem. We're not designing the process. And we definitely do not know anything about the data generating process. So one of the things that we want to do is to look at how does an economist approach this, or at least would like to approach all problems. It's this. We start with the question. We move to the answers. And at that point, we haven't seen any data whatsoever. Amazing? Yeah, well, that's what we do. Articulate a problem. Try to figure out how to answer that problem. Discuss what the possible answers will be to that problem. Try to figure out what will lead to those answers. Identify your structure. Work on a model specification. Are we asking the right questions? Are we committing type 3 errors? We go through this list in part of, that Kennedy puts up, and we say, okay, I know what I want to do. I know how I want to do it. Now let's take a look at the data. And the problem that's solved by that is data will lie to you. Looking for association does not guarantee causality. Looking for causality will guarantee that the associations you find will fall into a case of confirming or denying that causality if well structured. Again, it's a very high bar, but it's how we try to do our work. So applied work really comes down to taking theory and statistics into data analysis, articulating that problem, then acquiring the data, then not skipping the hard step, unless you think those were the hard steps. Cleaning that data, again, some people say that's 80% of the job. Cleaning the data and doing the transformations so that it will match the model that you want to look at and the things you want to look at, that data preparation. And then when we get to model specification, it's not a hasty model, or as Susan Athey says, who's probably the most skilled in machine learning and causality and what economists do. Uh, Susan Athey says many economists, indeed, act as if their model was given to them by God. Why? Because here it is. Here's my estimates. Here's my results. But no sense of what Kennedy suggested a few screens back. Do a sensitivity analysis. How sensitive are your results? Did you do linear regression? Well, what about nonlinear? How about nonparametric? How about other specifications? How about testing other influences that maybe you didn't think about? This is costly and it is takes time, but it is certainly the way that one has to do the work. So, in the rest of these parts, I'm going to be talking about cross-sectional data, uh, not time series where variables are ordered over time, or not panel and longitudinal data, although a lot of things I talk about in here will apply. But these are where you follow the same individuals over time, or you follow the like individuals over time. In other words, every year you're interviewing 12 to 14-year-olds, 15 to 16-year-olds, and so forth, and collecting their answers. So either you're following the same person over time, longitudinal, or you're looking at different individuals in those categories. Those would be special cases of the cross section. So I hope this was helpful to you, and join me for the other parts.